So today we are gonna learn about the triangles. As you can see here, we have got some pictures of triangles. And triangles are those geometrical figures which are made up of three lines and contains three angles. Hence the name triangles. Let us have a bigger picture of a triangle and observe it more carefully. Let's say we have a triangle with sides A, B and C. Can we name the side AB as 1, AC as 2 and BC as 3? The angle contained between the side AB and AC be A, AB and BC be B and BC and AC be C. Now that we have seen the angles and the sides of a triangle, can we determine if there is any relation between the angles?
Sides.
And for that, let's have a pair of lines drawn containing the angle alpha between them. Let's draw another pair of lines that contains the angle beta between them. Let's have a third pair of line which contains the angle gamma between them. Now if we happen to draw perpendiculars, we will observe as the angle changes, so does these sides. So can we say that the sides are proportional to the angles of a triangle? Now let's have another triangle that contains the angle alpha, beta and gamma. So there can be a possibility that the angles alpha is equal to beta is equal to gamma. There could be another possibility as well, where alpha is equal to beta but not equal to gamma. Then there could arise a third possibility where alpha is not equal to beta and that is not equal to gamma as well. So let's take the example of case 1 now, where alpha is equal to beta is equal to gamma. So let's have a triangle drawn with the side ABC that contains the angle alpha, beta and gamma. So the side opposite to angle alpha is BC. The side opposite to angle beta is AC and the side opposite to gamma is AB. So here we can see, since alpha is equal to beta is equal to gamma, the sides opposite to them will be equal as well. Therefore BC is equal to AC is equal to AB. Now that all the sides of a triangle are same, we call it as an equilateral triangle. Let us have a look at the case 2, where the angle alpha is equal to beta but not equal to gamma. Let's again draw a triangle with the side ABC which contains the angle alpha, beta and gamma. The side opposite to alpha is BC and the side opposite to beta is AC and the side opposite to gamma is AB. Now that alpha is equal to beta, we can say that BC is equal to AC and that is not equal to AB, as beta or alpha is not equal to gamma. So these kind of triangle where we have two sides equal, we call it as an isosceles triangle. Let's have a look at the third possibility, where alpha is not equal to beta nor gamma. So let's have a triangle drawn the side ABC that contains the angle alpha, beta and gamma. Here the side opposite to angle alpha is BC, the side opposite to beta is AC and the side opposite to gamma is AB. Since alpha is not equal to beta, we can say BC is not equal to AC, which is also not equal to AB as well, as none of the angles are equal. And the triangle where none of the sides are equal, we call it as a scalene triangle. Now that we have seen the three angles of a triangle, the question now arises, what will happen if we add up all these three angles? Let us have a triangle ABC that contains the angle alpha, beta and gamma. Now in order to add them up, we can use various ways. Let's use one of these easy ways, which is to have a line drawn parallel to the base BC. And as the line runs parallel to the base BC, AC and AB can act as transverse line. And we can see that the gamma will be next to alpha and so will be the beta because of the alternate angles. Now here we can see that the beta, alpha and gamma lies in a straight line, and the angle of a straight line we know adds up to 180 degrees. Angle of a straight line. Let's have a triangle drawn again with the side ABC that contains the angle as alpha, beta and gamma. Let's extend the side BC. Let's repeat the same with the side CA and extend it. Let's extend the side AB as well. And when we do so, we observe that we get angles such as P, Q and R as exterior angles. So what will be the value of P now? Now looking at the angle of a straight line, can we write the value of P as 180 minus gamma? Similarly, can we write the value of Q as 180 minus alpha? Similarly, with R as well, can we write it as 180 minus beta? Now if we happen to add all the exterior angle, we will see that the 3 180 will add up to give us 540, and in the bracket we'll have alpha plus beta plus gamma. A little while ago, we just learned that the sum of internal angle of triangle adds up to 180 degrees. So we can use it here, 540 minus 180, and that will result to 360. Now this can be done in another way. Add up P plus Q plus R and you get 180 minus gamma plus 180 minus alpha plus 180 minus beta. Here we know all the 180s will add up to give 540 minus the alpha plus beta plus gamma. Now we know that 540 minus 180 will add up to give us 360. So the sum of exterior angle results to 360 degrees. Now here's a point to observe. If we draw the triangle again, let's have a triangle drawn. The side ABC that contains the angle alpha, beta and gamma. Now we extend the base and have an exterior angle, let's say as P. We learned that P is basically 180 minus gamma. And we also know that the sum of interior angle is also 180 degrees, as in alpha plus beta plus gamma is 180 degrees. From here, we can say that alpha plus beta is equal to 180 minus gamma. So can we now say that the alpha plus beta will be equal to P as well? Or in other words, sum of interior angles is equal to opposite exterior angle. So I hope you enjoyed watching this video. Thank you for watching and have a good day.